All right, so we're talking about Unit 3, Entry 1. This is the matter unit. So the first thing we're talking about is how do we classify matter. And last unit, we had talked about this briefly at the beginning in our first entry, that matter is what makes up stuff. Everything in the universe is made up of atoms. Whether it's a solid, a liquid, a gas, or a plasma, those are the states of matter, what state it can be in. But we define matter as anything that has mass and takes up space. So we're talking about chemistry, which is our focus so far this unit. It's the study of composition, structure, and properties of matter and the changes that it can undergo. So if you look at the photo on the bottom right here, we have iron, but as it rusts, it undergoes a chemical change, and the evidence of that is that a color change. And if you notice, we go from atoms of iron to molecules of iron oxide, and that's what's happening as it rusts here. Our states of matter, as we know, solid, liquid, and gas. We just have some things fixed or defined shape and volume, or undefined shape and volume. So an element is a substance that cannot be broken down into simpler substances by chemical means. So all of our matter is composed of different types of elements. And the chemical formulas have, a chemical formula for an element has just one type of element in it. Here, aluminum, oxygen, and magnesium. Oxygen, even though it's O2, like in the air, is O2, it's still just a pure element because it's one type of element in it. Okay, the 2, that subscript, is still a piece that's can be found in elements or compounds. And an atom, so here this would be an atom of aluminum, an atom of magnesium, and a molecule of oxygen. For an atom is the smallest unit of an element that means the properties of that element. Okay, so like a single atom. So an element is one type of atom, and you have pure substances for them. So copper, carbon, or helium as an example of different elements. And in our Earth, in the Earth and human body, we have different elements, and it might be really shocking that the by mass, the most common element in your body is oxygen. And if you had to say, what are you mostly made out of? You'd say, well, I'm made out of water, which is H2O. And even though it's H2, that one O is 16 times heavier than one oxygen. So that's what you have there. And if you look at the Earth, primarily composed of iron in the core and oxygen in the air as well, and in other compounds. So elements, when they combine together, they form a compound, which is when you have atoms of 2 or more different elements that are chemically bonded. And here again, I see these subscripts in my examples, aluminum oxide and magnesium oxide. This is Al2. There's 2 aluminums and 3 oxygens in that one molecule of aluminum oxide. And here in one molecule of magnesium oxide, I have 1 magnesium and 1 oxygen. And just like every element has unique properties, every compound has unique properties as well. And then every time I have, so like an example here, I have carbon monoxide versus carbon dioxide. That too matters, because when I have just CO, that's a different compound than CO2. Every compound has a specific and unique ratio of elements. And like right here, I got CH4, that's methane. And then I have over here octane. Those are different compounds. Because I have a different ratio of carbons to hydrogens or carbons to oxygens, which means they have different properties. So whenever I have carbon monoxide, it will always be 1 carbon and 1 oxygen, because it will always be in that ratio. Carbon dioxide is always going to be CO2. And if I change the number of C's or O's, then it's going to be a different compound with different properties. And these are different examples of structures. We have ammonia, hydrogen peroxide, water, and carbon dioxide. If you notice, water is H2O, hydrogen peroxide is H2O2. Their structures look a lot different as well. But these are all molecules of those compounds. So a molecule is the smallest unit of a substance that have all of the physical and chemical properties of that substance. So we have pictures over here, water, oxygen, or sucrose, which is a type of sugar. Molecule acts as a unit, but it's always when you have 2 or more atoms bonded together. And you can have different ratios and combinations, as we just saw here, of water and hydrogen peroxide. So you get millions of different compounds, millions of different molecules. And the small changes can make a big difference. And here's a nice meme to illustrate that. So I'm a chemist, so I'll have some H2O, that's water. I'll have some H2O2. They drink them. This person doesn't do so good because H2O2 is hydrogen peroxide. Nice funny joke there. So these are all different molecules, but they don't all qualify as atoms. So this is an atom of oxygen, atom, 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 atom. But these are all molecules down here. So within our matter, and we saw this a little bit, and we won't get as specific as we talked about last unit, but pure substance is anytime you have one type of atom, one type of molecule, or so forth. So I could have an element or a compound. That's a pure substance. It has unique chemical and physical properties. But a mixture is kind of a little bit different. So again, if I'm looking at a chemical formula, if I have just one type of molecule, one type of molecule, one type of atom, one type of molecule, it's a pure substance. So both elements and compounds are pure substances. So I can look at it this way. Elements, I can have atoms or molecules. Compounds, I can have molecules or ions. This is a specific type of compound we'll talk about next unit. But they're different than mixtures. So if I look at up here, a compound, I have water, H2O, all bonded together. Everyone is the same. 2 H's, 1 O, 2 H's, 1 O. And over here, I have some H's and some O's that are separate. They're not bonded together. That means that they are a mixture. And those things are what we call physically mixed. Here we have chemical bonds. Here we have a physical mixture. And those physical mixtures means I can separate them without changing the properties of those substances. And we classify mixtures by how mixed they are. So when I look at matter, we got our pure substances, elements or compound. We have mixtures. We have two types, homogeneous and heterogeneous mixtures. Homogeneous mixtures are evenly mixed and heterogeneous mixtures are unevenly mixed. Or we'd say not mixed uniformly. And homogeneous mixtures are evenly distributed. So anytime you have gases, we call those homogeneous mixtures. So like air is a very good example of that. Metal alloys, rain, or oftentimes are like liquid mixtures are considered homogeneous mixtures. And heterogeneous is when it's not the same. So like here I got clusters of ice cubes and water throughout. Soil, if I went and dug it in my backyard versus at the school, those soils aren't going to be the same. Oil and water, oil and vinegar, those don't mix. And cereal, every bite is maybe a little bit different. So I can separate mixtures through processes such as boiling and filtering. We'll talk about this one in a second here. But here if I have water and ethanol, which is a homogeneous mixture, and I heat them, ethanol, which has a lower boiling point, is going to boil first. And it's going to turn into a gas. It's going to evaporate. And then this process here is going to cool it and then turn it back into a liquid and be able to separate it. So that means that the mixture will boil at about 60, I think, degrees Celsius until all the ethanol is gone. And then the water will it'll heat up again and boil at 100. And that's a way that you can separate two liquid mixtures. And over here, you start with a mixture that you're separating with filter paper. Then you put the filter paper into a dish and you're able to separate based on other properties such as magnetism. So if I have oil, water, sand, and iron, I can separate the water out through filtering and then separate my solids based on a separate property such as magnetism. And this process of boiling and cooling is how they separate crude oil into its different compounds. So both of methane and octane are hydrocarbons, and we call them hydrocarbons. So crude oil has a mixture of different hydrocarbons in there, and you can separate them based on their boiling points. And that's what happens in this process. And that's just kind of the basis here. So when we have solutions or mixtures of liquids, when we call them miscible when they can mix together. So like in this mixture, you have ethanol and water. There's very clearly no dividing line. They're clearly mixed together. And immiscible or immixable cannot be mixed, such as oil and water, where you'd see a distinct separation of the compounds. So when you talk about most of your household solutions, most of these are going to be liquid-liquid mixtures in some context. Isopropyl alcohol or vinegar, that's a miscible solution. Immiscible solutions would be like salad dressings, like Italian dressing, where you have water and oils in there as well, and then you got to shake it up before you dump it on. When we're talking about making solutions, you have two different pieces. You have the solute and the solvent. The solute is what you put in. It's what's being dissolved, such as salt and salt water. And the solvent is what's doing dissolving, and that's going to be basically water. So if I add a solid into water, say I'm making Kool-Aid, the solid powder goes in, it dissolves and separates, and I create a mixture of water and Kool-Aid powder, or solute and solvent. So last thing to make note of here is just take a moment and jot down any of these mixtures that you have here, solute and solvents, and what type of solution it is. These are all solutions. Notice solid ones, you got like brass, steel. Liquid ones, you got soda water, vinegar, seawater, whatever it might be. It tells you the solute and the solvent. Air, your solute is oxygen, because this is a smaller part. And nitrogen, which is the biggest part of our atmosphere, would be considered the solvent. So what I want you to do now is just complete the homework on the next 2 pages. And I know it looks like a lot, but we'll have a walkthrough posted tomorrow. So pure substance or mixture, iron is an element, which means it is going to be a pure substance, and it's just going to be an element. So feel free to abbreviate. Water, H2O, that's a compound, which is also a pure substance. You're just going through, looking at them and saying, is it an element, a compound, a pure substance, or a mixture? So these two are going to be my pure substances. Oops. And these things are going to be homogeneous or heterogeneous. These are going to be my mixtures. Okay, remember, homogeneous means the same. The way I remember that is it has 2 O's, which is the same. And here I got E's, and O's. I got a mixture of letters, so that is unevenly distributed. Then you're going to compare and contrast atoms and molecules in homogeneous and heterogeneous mixtures. And then you're moving on to the last page, which is classify each of these things as an element, compound, a mixture of elements, mixture of compounds, or a mixture. So here, notice that everything is the same. It looks kind of like water, which is probably what that is. So that would be B, a compound. I'll jump to number 8 here. Here, that's an element. That's an element. Those are different elements. And then I also have a compound here. So I have a mixture of elements and compounds. That would be like letter E. So I'm looking at their physical shapes. And let's go down to this one here. I got 1 white and 2 black. I got 2 white and 1 black. Those are 2 different compounds. I got 4 black and 2 white. And here I got 4 white and 2 black. So that's a bunch of different compounds. So that would be like letter D, a mixture of compounds. Okay. And then you're labeling these based off of their formulas as well. So like aluminum is a single element, so it's just E. Okay, so it sounds like a lot, or it might look like a lot, but really this stuff should go pretty quick, these last pieces. And like AlO2, that's a compound because I got aluminum and oxygen present. And when you're done, move on to the next thing. And tomorrow you can always check your answers with the homework walkthrough. All right, guys, love you, appreciate you. Have a great week, and we'll talk to you soon.